Now in the last video we saw about variance and expected value. So let me rewrite what is expected value. So expected value we saw is sigma x times probability of x. So this is for a random variable. We saw this is the formula, or we also saw this is basically the mean, or written by the Greek letter mu. So this is mean, and then we saw variance of x. Variance of x can be defined as the expected value of x squared on n minus the expected value of x the whole squared. Now let's think about what will happen if a random variable is multiplied and added by a number. What would happen to the mean and what would happen to the variance? Okay, so let's take a random variable x. Let's say the random variable x is 3, 5, 6, 8 and 10. 3, 5, 6, 8 and 10. So let's find the expected value. Expected value is just the mean, so you have to just add them up. So it is 3 plus 5 . So if you add them, it comes to 32 on 5, which is 64 on 10, which is 6.4. Okay, and we know the variance of x is basically squaring this number. So let me write it. So this is 3 squared plus 5 squared plus 6 squared plus 8 squared minus the expected value squared, which is the mean squared. So you can do this on a calculator, and you will find the variance comes to 5.84. Okay, now just to confirm, so from this we can say this implies the standard deviation of x is square root of 5.84, which can be calculated also by a calculator, and I worked this out, which is 2.4166. This is onto 4 decimal points. So let me show this on a calculator. Okay, so go to spreadsheet and enter x, and let's enter 3, 5, 6, 8 and 10. Okay, and then you go under menu, statistics, stats calculation, one variable statistics, and then it'll ask you number of list is 1, and it'll ask you what's the x value, which is x. List is 1, and then if you scroll down, so this is your mean, this is 6.4, which was confirmed, and if you scroll down to sigma x, which is 2.4166. okay, so now what would happen if I multiply each of these x's by 2 and add 3? So let's find what is going to be 2x plus 3. 2x plus 3 is basically multiplying each by 2 and adding 3. So 3 times 2 is 6, 6 plus 3 is 9, 3 times 2 is 6, 5 times 2 is 10 plus 3 is 13. The next is 6 times 2 is 12, 12 plus 3 is 15, Am I right? Yeah. 8 times 2 is 16 plus 3 is 19, and 10 times 2 is 20, 23. Okay, now let's find the expected value of x, which is the mean of x, which is 9 plus 13 plus 15 plus 19 plus 23 divided by 5. So what's going to happen, you can add this, use a calculator. This adds to, if you do the divide by 5, I have worked it out, it is 15.8. Now let's see whether there is a relation between 5.8, no, not this, sorry, 6.4. How? Without doing, if you just know this mean, and if it is told that the random variable is multiplied by 2 and added 3, from this can you get this? That's the question. Well, let's see. So this is, let's call this the old mean and this is the new mean. So let's whatever we did to all the data, can we do to the mean, old mean, and get the new mean? So I'm multiplying the old mean by 6.2 and then add 3, which is 12.8 plus 3, which is 15.8. So this is a formula you can remember. New mean or expected value is old, I'll write expected value because we are using expected value, old expected value times whatever you're multiplying. Let's say that is A plus B. So this is a formula. We can say the expected value of AX plus B, expected value of AX plus B is same as A times the expected value of X plus B. Now let's see what happens when what happens to the variance when you're multiplying the old random variable by a number and multiplying by a number and then adding a number. So let's write 2x plus 3 again. So 2x plus 3 is we already saw, that is 9, 13, 15, 19 and 23. So let's see what happens to the variance. Okay, so let's say the variance of 2x plus 3 is basically the data squared, the random variable squared, so 9 squared plus 13 plus 15 plus 19 plus 23 divided by 5 minus the expected value of the, that is basically the value 9 plus 13 plus 15 plus 19 plus 23 on 5. Okay, so well, you can do this on a calculator, and the variance you will find is 15.8. The variance of 2x plus 3 is 15.8. Okay, let me show this on a calculator. So this is a Casio calculator. Okay, I want to see the data. So we know it is 9 squared. Okay, so go, okay, menu, run. So let me put this in the bracket, 9 squared. Let me bring it down slightly so that you can see the data. 9 squared plus 13 squared plus 15 squared 15 squared plus 19 squared plus 23 squared. I think I've written a mistake, so you have to square the data divided by number of data. This is expected value of x squared minus again, let's do, you add the data, which is 9 plus 13 plus 15, hopefully I've not done any mistake, plus 19 plus 23, close the bracket, divide by 5. Let's see, 250. Okay, so I made a mistake here, 19 squared plus 15 squared. So yeah, so this is the square of the x's divided by 5. I worked this out, so, and we'll confirm it. So this is square root of 15.84, and from this we can say the standard deviation of 2x plus 3, we'll check this on a CAS calculator, the this would be okay, sorry, this is a mistake, so this is not right. I have, this is the expected value of x. Okay, so yeah, the final answer, the variance is 23 point, okay, so I have worked this out, so this is 1365, you can check that on a calculator, on 5 minus 15.8. so if you add them and divide by 5, it is 15.8 the whole squared, and that's all. That's what we checked in the first part. So this is 2 times 6.4 is 12.8 plus 3 is 15.8, and that came to 23.36. And so we can say the standard deviation of 2x plus 3 is the square root of this number. Okay, so 23.36. So let me use my calculator. So cancel, shift, square root of 23.36. We'll confirm this, which is 4.833. 8332. So 4.8332 into dp. We'll confirm this later. Now this is just to see whether our working is right using a CAS calculator. But what is my focus is, what is the relationship? What is the relationship between the old variance, so this is the new variance, and the old variance that we had is 5.84. Now just on a calculator, if you go 4, now you have multiplied each of the data by 2. So here let's do 2 squared times the old variance. The old variance was 5.84. So 2 squared times 5.84 will give us what? So let's use a calculator. 2 squared times 5.84, which was the old variance, which is 23.36. Okay, so basically the formula is the variance of ax plus b. When you're adding something to the data, this b doesn't make any difference to the variance. So the variance, so let me write it properly. So variance of, so we can say variance of ax plus b is equal to the square of a squared times the variance of x. So whatever you're multiplying the data, you square that number and multiply by the old variance will give you the new variance. So let me show you this number to confirm that our calculation is right. So on CAS, You can just type in here. Let's type in just that as x1. That's a new data. And we can also let's go up, so you can go equal 2 times x plus 3. So it will populate the data by itself, change that into variable reference. Okay, so this is the data that we had, 9, 13, 15, 19 and 23. So let's find the mean and the standard deviation. So again, go menu, stats calculation, okay, and make it x1. I want to find the value. The new list is x1. Okay, make it variable reference. Okay, and if you want to override, yes. So if you go scroll down, this is the new mean, which is 15.8. we checked, and the standard deviation is 4.833. And this is what I said, this is the square of x squared and 1365, and this is the standard deviation, new standard deviation.